Hello, this is Jeff Hamrick at Rhodes College again, and I'm going to spend a few minutes talking about how you use bar charts to create basic graphical representations of a set of data that you'd like to study. In particular, bar charts are going to be useful when your data is either dichotomous or categorical in one of the variables, probably both of the variables, in fact. So here's how you use Fathom to visualize your data. This is the data from the quiz we took the other night, where we have a computer system that predicts whether or not the market will close up or down each day, and then the actual result from what actually happens in the real stock market every day. So if we drag down an empty graph icon, you'll recall that this is what we do when we are finished doing a randomization procedure and we're trying to create a drawing of a randomization distribution. We can also use this graph icon to make basic graphical representations of data in Fathom. If I were to take one of my attributes from this table and simply drag it directly over here, it'll create a bar chart in which the bars point upwards. So what this bar chart tells me, roughly speaking, is that in approximately 50 plus 40 or 90 trials, the computer predicted that the stock market would end up 50 times, and the computer predicted that the stock market would end down 40 times. If I drag down another graph icon right here, and I take the other attribute, the actual result from the market at the end of each day, and I drag that over here, but drag it instead to the y-axis rather than the x-axis, I get a bar chart in which the bars are horizontal instead of vertical. And it's not really telling me anything particularly interesting in this case. In this case, it's telling me that in this collection of 90 days, we had 45 days on which the market closed up and 45 days on which the market closed down. So roughly speaking, during these 90 days, the stock market was sort of neutral rather than bearish or bullish. I'm going to go ahead and delete both of these bar charts and talk about creating a multi-bar chart. So if I drag down an empty graph icon and then I drag the computer's prediction here, we think of that as being the thing that determines or explains the market result, and then I now drag the market prediction, the actual market result attribute, over to the y-axis here. The bar charts split and I get a multi-bar chart right here. And let's run through this quickly, what this bar chart sort of suggests. It's telling us that when the computer predicts that the market will go up, the market result is actually up a very large amount of the time compared to when the computer predicts that the market will go up, but the market actually ends up going down. These bars seem to be of very, relatively different heights. 30 instances here, 20 instances here. When the computer predicts that the market will go down, the market is down a fair amount of the time compared to when the market goes up, even though the computer has predicted that it will go down. So this sort of bar chart representation of this data over here in this 2x2 frequency table suggests intuitively to us that the computer is doing a pretty good job predicting what the stock market will do. Of course, is it making correct predictions enough of the time that we would, in a statistical sense, say this computer program is doing a great job? Well, that's a question that's best left for a randomization procedure or a formal statistical test. And right now we're just talking about graphical representations. So this is how you create simple bar charts and multi-bar charts in Fathom.